Hi, my name is Thomas Kim. This is my sixth video in MFC with Direct 2D graphics video series. Okay, let's start. I copied and pasted my previous video, my previous source code and renamed it like this, and I prepared it already to speed up this video. If you cannot see your property window, you can open it. Okay, say in the class. Uh-huh. Here, initialize. And this is the last file we have done before. This is the state of the files from previous session to let's see. Here transformation. We will add one more. Okay. We will add one more function in here. Okay, draw. It will be like a void draw axis. Okay. Draw axis. And here right before initialize, we will draw axis ch wind. We need wind target p, render target, this mp view, get render target. We need a brush. Brush will be black brush. Render target D2 D1 color. Okay. Now we are drawing coordinates axis. Okay. Render target. Draw line. CD 2D. Point up. CD. I will do 2 points. This is starting point. We will need a brush. This will be this M range, negative x, y coordinate. This is R. Draw y-axis. Y-axis should be y d. No, should be changed. Y up value. If you cannot understand what these points are, then you probably have to watch my previous videos. To follow with me, you have to remember what we have done in our previous sessions. Okay. Now I will add draw axis here, copy, and here paste. Draw axis. Draw axis would be initialize. As before, we copy axis. Okay. I save all here. Here again. I will set it to 300, 300, 200, 300, 300. Now we will draw quadratic equation. Then I will set draw axis. It draws axis, and let me see. And the target. I will create two brushes. Black brush, P render target, D2, D1, color, black. I will create one more. Sorry. I will create one more. Red. It will be red. Okay, I created two brush. This is black brush. This is red brush. Okay. What's next? I will draw a quadratic equation like this. I need 2 points, C, D, 2D, point, up, PT, order, PT, new, PT, all the x equals, O, yeah, times, here the x would be minus range 300. Then PT or the y would be times minus 150. I will make it like this, and coefficient 0.0 times this would be like this, y equals L times x minus 250 something like this, the same equation, equivalent. Now this, let's go from pt new x pt old x plus float and see. I will have like functional inc pt old x should be pt old should be 300 0f pt new x should be nc. It should be pt new here. Let's see, I have to use this equation once again, but pt new pt new. Okay, so pt new. Okay, p render target, draw line. We need all the point pt old pt new black brush. Okay, let's compile it. Let's build and test it. Okay, let's try. Oh, what's the matter? We forgot one thing. pt new equals pt old equals pt new. Okay, this is quadratic equation, and I will introduce lambda function in C++ language. Then I will change it to something like this: auto q u quadratic equation QE. I will write this lambda function. We need to have a float x. This function should return float. Then here return 1 up times x minus okay, this is lambda function. Just single line. Then instead of this, I would write this like this: QE pt old x, like this. And here we will be doing QE pt new x, and rest is the same. Okay, let's try it. The results are the same because we haven't changed anything. Since this is a lambda function, we can change it to like wider, to make it wider, like let's try what it looks like. So lambda function is very convenient. Okay, now we will introduce another function. We will draw a circle. How are we gonna do that? I will introduce another function. Let me see. Arctangent 공 ATANF 공 returns pi over 4. So pi should be pi radian in radians. Pi radian should be ATAN arctangent F 1 point times 4.0 F. So pi radian is 180 degree. So from here 1 degree equals pi over 180 radian, and so x degree becomes x times pi times 80 radian. Okay, from this we would let constant close pi equals arctangent 1 of 0 F times F. This is pi can't plot pi ratio should be pi times F. Okay, so let's see. We make another lambda function called radian. This should be this should accept pi ratio and plot x should return pi x times pi ratio. Okay, this is another radian function. So this converge x degree is equal to x radian x. Now let's make a circle circle this should use radian, and accepts plot theta. Theta is angle, and region CD to the F. C to the point F. Then return plot RID radian theta return C D to the F, D to the point F, D to the point F, radius. I will put another here. Plot radius. Radius would be 100 0f. And we should put radius here. Radius of circle times x sine and cosine f already. Radius times sine f already. Okay, this is x. This is y. X co-order x y. X component component of a point, y component of a point. Okay. Okay, this is circle of radius. Circle of radius 100. Now let's go. We need to have a plot. Theta is degree theta. First point PT old x. No, we can have like this. PT old circle. We are starting from first point. We don't need it. Plot theta would be plot INC should be 6.0 the easier EE. So INC theta should be degrees theta INC. PT new should be circle theta returns points, a point on circle. P when the target, draw line, PT old, PT new, red brush. Okay, we have PT old equals PT new. Okay, let's go. We can just do this. Okay. Wow! This is circle, this is quadratic equation. Okay, so in this session we used mapping transformation. This transformation, where it is, set transformation that we developed in previous sessions, and this is new function we introduced, draw axis, and we introduced quadratic lambda function. This is quadratic equation, and we also created another lambda function. This is circle. No. Two more lambda function. This converge radian. This radian converges from from degree to radian. So because cosine f and sine f accepts, the argument should be angles in radians, so we convert from degrees to radian. And this circle function, lambda function, actually returns point. It returns point. So return statement, we used radian, and this theta is actually degrees. So we used this way. We draw circle. Thank you for watching.